Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now, lying down, settling in, letting the day begin to loosen its hold, this is a good place to be. There is nothing you need to do here, nothing to solve, nothing to remember, nothing to carry. Just this voice, and the quiet, and a few gentle truths about the star that has watched over every single day of your life. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. There is a kind of light that is older than the sea. Not older in the way we say things carelessly, but genuinely, measurably older. Before Earth had a single ocean, before the first raindrop ever fell, before water pooled into anything you could cup in your hands, light was already leaving the Sunday. It had already begun its long, unhurried journey outward. Picture the Earth before its oceans formed. A world of cooling rock and thin, strange air. No waves, no tides, no reflection of anything in any water, because the water had not yet arrived. And yet, even then, the sun was shining. Even then, photons were streaming out into the dark in every direction, carrying energy into a solar system that was still deciding what it wanted to be. The oldest sunlight left before Earth had oceans. That is not a poetic flourish. That is simply what the timelines tell us when we lay them side by side and let them speak. We think of sunlight as a morning thing, as something fresh, as something that begins when we open our eyes and ends when we close them. But the sun has been at this for so much longer than morning. It has been at this for so much longer than us. There is something deeply settling about that. You are resting tonight beneath a light source so ancient it predates the seas, and it is still here, still steady, still shining. You may not think of your skin as a listening instrument, but right now, if any warmth finds you through a blanket, through a window, through the memory of an afternoon, something in your body already knew what it was before your mind did. The skin registers heat through dedicated nerve endings, pathways that evolved over hundreds of millions of years, long before our ancestors could name what they were feeling. Warmth was information long before it was comfort. It told ancient creatures, this direction. This is where life is easier. This is where the cold retreats. And so your body still carries that ancient knowing. When sunlight falls on your arm, something responds before thought arrives. A small relaxation, a slight softening, the nervous system receiving a message it has been reading for longer than language. You are warmed by a star, not by a heater, not by a blanket, not by the friction of a world, by an actual star 93 million miles away, conducting fusion in its core, and sending the result to the surface of your skin without any mechanism in between except space itself and the patience of photons. Your skin knows this. Somewhere below the level of thinking, your body has always known this. You are in contact with a star right now, and your oldest, quietest self finds that entirely ordinary. Hold out your hand for a moment, or simply imagine it. Now imagine the sun beside it, not in the sky, not at its true distance, but here, in the room, to scale. A sphere so wide that 1 million objects the size of Earth could be packed inside it and still leave room. 1 million. And yet, when you step outside on a clear day, you can cover the entire sun with your thumb held at arm's length. It fits behind a fingernail. It becomes a thing you could occlude with a coin, a button, a closing eye. Distance performs this quiet magic. It takes something of almost incomprehensible size, and places it at a scale your eye can hold. The sun appears small enough to be gentle, small enough to watch without fear, small enough to feel like yours. The sun's diameter is about 109 times wider than Earth's. That is not a number to rush past. That is the difference between a marble and a large beach ball. Except the beach ball is made of plasma, fusing hydrogen into helium every second, and has been doing so for 4.5 billion years. And still, when the light reaches you, it is just warmth, just a soft gold on the grass, just the way the world looks in late afternoon, when shadows grow long and everything seems to slow. Vastness, when it travels far enough, arrives gently. Somewhere inside the sun right now, a photon is being born. Not a photon like the ones warming your window this moment. Those have already made their escape, already crossed the distance, already arrived. This is a new one, formed in the crushing, unimaginable pressure of the solar core, where hydrogen atoms are pressed so tightly together that they fuse, releasing energy in the form of a tiny packet of light. That photon begins to move, and immediately it hits something. An ion, a particle, a wall of density so extraordinary that the photon is absorbed and re-emitted almost at once, in a random new direction. Then again, a journey of pure randomness through a medium so thick that progress is nearly imperceptible. This process, scientists estimate, takes somewhere between 10,000 and 100,000 years. The photon you felt on your face this morning may have begun its interior journey before human beings had settled into agriculture, before the first city was built, before writing existed in any form, and then it reached the surface, and the surface let it go, and it crossed the vacuum between us in 8 minutes and 20 seconds, landing finally on whatever was first in its path. Maybe a leaf, maybe a window, maybe you. The light you live inside is ancient beyond your ancestry. It has simply been patient. There is a distance that is exactly right. Not a little right, not approximately right. Exactly, persistently, life-allowingly right. Earth sits at a distance from the sun that keeps liquid water possible, keeps temperatures within a range that proteins can function, keeps the sky blue and the seasons gentle and the nights cold but not fatal. Move Earth slightly inward and the oceans boil. Move it slightly outward and they freeze. The margin is not enormous. It is, in cosmic terms, quite narrow. And yet here we are, inside it. Here you are, lying in a room on a planet that found its way to exactly the right distance, held there by gravity, kept there by the mathematics of orbital mechanics, and maintained with such consistency that you have never once had to think about it. Not once. Not even tonight, when you are thinking about almost nothing. This is called the habitable zone, the Goldilocks region, the place where things are not too hot, not too cold, but with a patience the universe does not usually bother to explain just right. You live in a place that is precisely suited to you. That precision required no intention. It required only physics, and time, and the particular arrangement of one star and one small world. But you can still feel, if you let yourself, how extraordinary it is to be exactly here. Light, it turns out, does not move freely inside a star, outside a star, in the open vacuum of space. A photon travels as fast as anything in the universe can travel, crossing from the sun to your eye in just over 8 minutes. Nothing slows it. Nothing interrupts it. It moves as if the universe has cleared a path. But inside the sun, the story is entirely different. The interior of the sun is so dense, so packed with plasma and ions, and the constant pressure of a star holding itself together, that light cannot move in a straight line. It ricochets, It is absorbed and re-emitted, absorbed and re-emitted, stumbling through the interior like someone trying to cross a room in total darkness, reaching out in every direction, finding a wall each time. The zone it must cross, the radiative zone, stretches for hundreds of thousands of kilometers, and the journey through it takes, on average, somewhere in the range of 100,000 years. 100,000 years to cross the inside of the star, then 8 minutes to cross the space between the star and you. Containment takes almost everything. Release takes almost nothing. That is true of stars. It may, quietly, be true of other things as well. You wake in the morning and sunlight is there. You fall asleep at night and the sun has set. But you do not think much about where it has gone. It has become, for most of us, as automatic as breathing, as reliable as the floor beneath our feet. But consider for a moment what is actually happening when sunlight reaches you. A photon leaves the surface of the sunday. It travels 150 million kilometers through empty space. It enters Earth's atmosphere, where particles begin to scatter it. It passes through cloud, perhaps, or glass, or the thin membrane of a curtain, and then it lands. The whole journey from the sun's surface to your eye takes 8 minutes and 20 seconds. If the sun were somehow switched off, you would not know for 8 minutes and 20 seconds. You would still be sitting in the light of a star that was already dark. But the sun has not been switched off. The sun has not faltered in 4.5 billion years. The light arrives this morning, as it arrived on the morning your grandparents were born, as it arrived on the morning the first humans opened their eyes on a cooling savanna. 8 minutes and 20 seconds. That is all that stands between you and a star. Closeness is not always visible, but it is real. We call it burning. We say the sun is burning the way a fire burns, because that is what it looks like. That is what it felt like to the people who named it, who sat beside their own fires and looked up at the greater fire above them and drew the comparison that seemed most obvious. But the sun is not burning. Fire requires oxygen. The sun has no need of oxygen. What is happening inside it is something quieter, something more fundamental, something that did not even have a name until the 20th century. The sun runs on nuclear fusion. At its core, hydrogen atoms are compressed under pressures and temperatures so extreme that they overcome their natural repulsion and merge, forming helium and releasing energy. Not burning, merging, becoming each other, and releasing light in the transformation. It is, in a sense, the opposite of burning. Burning destroys structure. Fusion creates it. Burning leaves ash. Fusion leaves helium, and light, and warmth, and the slow continuity of a star that has been quietly embracing itself for longer than Earth has been a world. The sun is not consuming itself in violence. It is sustaining itself in a slow, steady act of union, pressing itself together so gently at the scale of atoms that the result is every morning you have ever woken to. There is something almost tender in that, when you let yourself feel it. Your bones are not yours alone, not entirely. The calcium threading through them, the mineral that gives them their quiet solidity, was not made here. It was not made on Earth, and it was not made in this solar system. It was forged inside a star that lived and died before our sun was born. A different star, an older one that ran through its life, collapsed, and scattered everything it had made into the cloud of gas and dust that would eventually become us. That process is called stellar nucleosynthesis. Stars fuse lighter elements into heavier ones across their lifetimes, and when they die, they release those elements into space. Calcium, carbon, iron, oxygen, the raw materials of living things, made in dying suns. So when you feel the weight of your own body, the density of your own arms, you are feeling the inheritance of stars you will never see. Stars that were already ancient when the sun ignited. Stars whose names, if they had names, no one remembers. You did not come from nothing. You came from everything that came before. And that lineage is written not in language, but in the precise arrangement of matter in your bones. You are older than you think, and that is not a frightening thought. It is a generous one. There is a sound the sun makes, not a metaphor, not a poetic reach, an actual, physical, measurable sound. The sun produces acoustic waves, pressure waves, that ripple across its entire surface continuously, the way a bell rings after it has been struck. Except the sun was never struck. It generates these oscillations from within, from the churning and convection of plasma moving through its interior. This field of study is called helioseismology. Scientists translate the sun's surface movements into data, mapping the interior of a star the way a doctor reads a heartbeat through the chest wall. The technique has revealed things about the sun's interior that no telescope could ever show directly. But the sound itself cannot reach us. Sound requires a medium, and space is very nearly empty. The acoustic waves stay with the Sunday. They move across its surface in patterns too slow and too vast for any human ear, even if you were standing close enough to hear. So the sun sings, in a sense, to no one, or perhaps to itself, a continuous, low, ancient resonance that has been sounding since before the earth had continents. Even now, as you rest in the quiet, the sun is humming, not loudly, not urgently, just steadily, the way very old things tend to continue doing what they have always done. Hold the weight of a single second in your mind. Just 1 second, the amount of time it takes to blink, to exhale, to let a thought go before it fully forms. A second is almost nothing. It is the smallest unit of time most of us ever actually feel. In 1 second, the sun releases more energy than human civilization has used in all of recorded history. Every fire ever lit, every engine ever run, every light bulb ever switched on across all of human time is contained inside a single heartbeat of the sun's output. The number behind this is so large it stops meaning anything if you try to read it directly. So do not try. Instead, simply hold the image, 1 second, 1 blink. And in that blink, enough energy to power everything we have ever built for 500,000 years. This is not power in the sense of something dangerous or overwhelming. It is power in the sense of abundance so complete that it becomes something closer to peace. The sun is not straining. It is not burning itself out. It has been doing this for 4.5 billion years, and it will continue for roughly 5 billion more. You are resting tonight in the overflow of something impossibly generous, and it asks nothing of you in return. The Milky Way is turning, slowly, by the standards of anything we can watch in a single life. So slowly that a complete orbit takes hundreds of millions of years. And in all the time the sun has existed, in all 4.5 billion years of its life, it has completed fewer than 21 of those orbits. 21 laps. That is the sun's entire life, measured in galactic years. It is, in a strange way, quite young by that measure. A modest number of circuits around a galaxy so large that the distance covered in each orbit dwarfs anything else we can imagine. Astronomers call one full orbit of the sun around the Milky Way a cosmic year, or a galactic year. 1 galactic year ago, dinosaurs had not yet appeared on Earth. 2 galactic years ago, complex animal life was only just beginning. The sun has been alive for less than 21 of these. There is something settling in that. The galaxy turns so slowly that even the sun, ancient as it is by human reckoning, is not yet old within it. The story is still early. The wheel has barely moved. You are resting on a planet in the early chapters of a very long book, and the book is in no hurry to finish. Every sunrise you have ever seen was a new one, not in the way we say things to sound comforting, in the way that is actually verifiably true. The sun is not a static object. It is a dynamic, living system, constantly changing. Its surface churns. Its magnetic field shifts. Sunspots appear and dissolve. Plasma arcs and falls back. Solar wind ebbs and gusts. The sun you watched rise this morning was not the same sun that rose on the morning you were born. It had moved through space. Its surface had rearranged. The precise configuration of energy pouring from it was different in ways too fine to see, but real nonetheless. And you have changed too. Every sunrise found a slightly different version of you standing in the light. A different age, a different understanding, a different arrangement of everything you had been through. This is not melancholy. It is the opposite of melancholy. It means that every morning is genuinely the first time that particular sun has risen for that particular version of you. It has always been a meeting between two things that have never met before in quite this way. The sunrise you will see next is one that has never happened, and neither, quite, have you. Above the sun's visible surface, something strange happens. The surface itself, the photosphere, the layer we see when we look at the sun through safe filters or projections, sits at a temperature of roughly 5,500 degrees, hot beyond imagining. And yet, as you move upward through the sun's atmosphere into the region called the corona, temperatures rise again, sharply, to millions of degrees. This should not happen. In almost every physical system we understand, things cool as you move away from a heat source. A fire is hottest at its center. A radiator warms the air nearest to it first. The logic of heat says, move away, grow cooler. But the sun's corona breaks this logic. It is orders of magnitude hotter than the surface beneath it, and scientists have been studying this problem for decades without a complete answer. There are leading theories involving magnetic waves and reconnection events, but the full explanation remains, genuinely and honestly, unknown. The sun has been our nearest star for our entire existence as a species. We have studied it longer than we have studied anything else in the sky, and it still holds a secret it has not finished telling. There is something quietly wonderful about that, the most familiar thing in the sky, and it is still surprising us. Right now, beyond every planet, the sun is still breathing. The solar wind is not a metaphor either. It is a real and constant outflow of charged particles streaming from the sun in every direction, at speeds of hundreds of kilometers per second. It fills the entire solar system. It reaches past Mercury, past Venus, past Earth, past Mars, past Jupiter and Saturn, and the cold outer worlds, all the way to the very edge of the sun's influence. That boundary is called the heliopause. It is the point where the solar wind finally weakens enough that interstellar space pushes back and wins. Everything inside that boundary is, in a loose but real sense, still inside the Sunday, still touched by it, still held within its breath. Earth sits well within that breath. We are not on the edge of the solar wind. We are swimming in it, protected by our magnetic field, which guides most of the particles safely around us. The auroras you have seen or imagined, those slow curtains of green and violet, are the places where the sun's breath and Earth's shield meet and glow. You are not separate from the Sunday, you are inside it, in a sense, living within the long, slow exhale of a star. There is a word for the place inside the sun where its magnetic field is born. It is called the tachocline, a thin, strange layer sitting between two very different zones of the sun's interior, where one region rotates as a solid body and another rotates differentially, faster at the equator than at the poles. The boundary between them is the tachocline, and the shearing forces created there are believed to be where the sun's magnetic field originates. The sun's magnetic field is not a minor detail. It drives sunspot cycles. It powers solar flares. It shapes the solar wind. It is the reason auroras exist. Everything dynamic and changeable about the sun traces back, in some way, to this hidden boundary layer deep inside a star. And we cannot see it. We infer it. We deduce it from surface measurements, from helioseismology, from the mathematics of a star behaving in ways that only make sense if something like the tachocline exists where we believe it does. The most powerful force shaping everything we experience of the sun begins in a place we have never directly observed and may never be able to. Some of the most important things are the ones we can only sense from a distance, through what they make, through what they change, through the light they cause in other places. 5 billion years is not a threat. It does not arrive like a deadline. It does not loom. It sits at a distance so vast that the mind simply cannot hold it as something urgent, the way it cannot hold the distance to the nearest star as something walkable. 5 billion years from now, the sun will begin to expand, slowly at first, then more. It will grow into what astronomers call a red giant, swelling outward past the inner planets, its surface cooling to a deeper, slower red. But that is so far ahead of where we are now that every mountain range on Earth will have risen and eroded away several times over before it begins. Every species alive today will have been replaced by things we cannot imagine. The continents will have rearranged themselves into configurations no current map could predict. The sun's eventual expansion is not a story about ending. It is a story about scale, about how long a quietly burning star can simply continue. 4.5 billion years behind it, 5 billion years ahead. The sun is, by any honest measure, in the middle of a very long and unhurried life. You are resting tonight at the midpoint of a star's biography, and the star is not worried. It is simply continuing, as it always has, 1 second at a time. Every beam of light has a biography. The one falling through your window right now, or the one you felt this afternoon on your face before the day turned quiet, did not arrive cleanly. It left the Sunday. It crossed the vacuum of space, which took just over 8 minutes. Then it entered the atmosphere, where molecules of air scattered some of it sideways and let the rest continue. It may have passed through cloud. It may have been filtered by glass, softened by a curtain, reflected off a wall. By the time light reaches your eye, it has already been changed many times, bent, scattered, absorbed by one surface, and re-emitted by another. The warm afternoon gold you see at low angles is the same light as the sharp blue of noon, transformed by how much atmosphere it had to cross and what that crossing did to its shorter wavelengths. Light is not delivered, it arrives, and arriving, for light, is an accumulation of small encounters, each one leaving a trace in the color and quality of what finally lands. Seeing is not a passive thing. It is the end of a journey. Every time you open your eyes in daylight, something that left a star has found you, after traveling through more than you can easily picture, to land precisely where you are, On the surface of the sun right now, a storm is ending, or beginning. It is difficult to say, because the surface of the sun is never still. What we call the surface, the photosphere, is a roiling, turbulent layer of plasma, constantly in motion. Convection cells, called granules, rise and fall, each one roughly the size of a small country. They form and dissolve in minutes. Beneath them, larger structures called supergranules move more slowly, spanning distances wider than Earth. And among all of this, sunspots come and go, dark regions on the surface, cooler than the surrounding plasma, caused by intense concentrations of magnetic activity that suppress the upwelling of heat from below. They look dark by comparison, but a sunspot is still thousands of degrees hot. It would blind you. It only seems dark against the brighter surface around it. These storms are enormous by any human measure. Some are larger than Earth. Many come in pairs or clusters. They travel with the sun's rotation and fade over days or weeks. No one is watching them with any urgency. They rise and fall as they always have, across a surface no one visits. There is weather on the Sunday Ancient. Vast, continuous weather, noticed by no one on its surface, felt gently by everything within its reach. The sun is middle-aged. That is not a poetic softening. That is the actual astronomical assessment. At 4.5 billion years old, our sun has consumed roughly half its available hydrogen fuel and sits comfortably in what astronomers call the main sequence, the long, stable phase of a star's life, where hydrogen fusion in the core proceeds steadily, and the star neither expands nor contracts significantly. Main sequence stars are the quiet ones. They are not the spectacular explosions at the ends of massive stars' lives, not the exotic remnants, not the collapsed objects that bend space-time visibly. They are the steady ones, the ones doing the same thing day after day, year after year, billion after billion of years. Our sun will remain on the main sequence for another 5 billion years or so before it begins to change. 5 billion years of more or less the same warmth, the same light, the same patient fusion at its core. There is something deeply comforting about that word, steady. The sun is not exceptional among stars for its power or its size. It is exceptional, if it is exceptional at all, for its consistency, for showing up, for being, in the language of astronomers, a quiet, unremarkable, beautifully dependable G-type star. The most comforting thing in the sky is also, by stellar standards, one of the least dramatic. The sky is a filter. When sunlight enters the atmosphere, it does not arrive the same way it leaves. The atmosphere is not a window. It is a prism, a scatterer, a transformer of what passes through it. Molecules of nitrogen and oxygen scatter shorter wavelengths of light, the blue and violet end of the spectrum, in every direction. This is why the sky is blue. Not because the sky is blue itself, but because blue light has been scattered so thoroughly that it reaches your eye from every direction at once. At noon, with the sun high overhead, light passes through the least atmosphere. Blue dominates. Everything looks clear and sharp and bright. At sunrise and sunset, the sun sits near the horizon, and light must travel through a much longer diagonal slice of atmosphere to reach you. Most of the blue has already been scattered away by the time it arrives. What remains is red, orange, gold, the colors of thicker air, the colors of longer journeys. The blue of midday and the gold of evening are the same light, changed by distance and angle, changed by how much of the world the light had to cross before it found your eye. Even the color of the sky is a record of a journey. Everything you see is a translation of something that has traveled a very long way to be seen. Somewhere in the 18th and 19th centuries, something changed. Scientists of that era, looking carefully at sunlight passed through a prism, noticed something they did not expect. The spectrum of colors was not smooth and continuous. It was interrupted. There were dark lines, precise and repeating, embedded in the rainbow. Hundreds of them. These lines are called Fraunhofer lines, named for the physicist who mapped them systematically. Each line corresponds to a specific element in the sun's atmosphere, an element that absorbs light at that precise wavelength as the light passes through on its way to us. The dark lines are absences, places where specific colors were removed before the light arrived. And each absence is a fingerprint. Sodium leaves its mark. Hydrogen leaves its mark. Iron, calcium, helium. Each one takes a specific color from the light, and the missing color tells us what was there. This is how we know what the sun is made of. From here, from this distance, without ever touching it, we read its fingerprint in the gaps it leaves in its own light. The sun writes its own composition into every beam it sends. We learn to read the writing. And the sun, it turned out, was not unknowable at all. It had been showing us what it was made of the whole time. There is a probe, right now, closer to the sun than any human-made object has ever been. The Parker Solar Probe was launched in 2018 and has been gradually tightening its orbit around the sun ever since, using the gravity of Venus to bend its path inward on each successive pass. It has entered the sun's corona, the outermost layer of its atmosphere, the region of mysteriously extreme temperatures we have already visited in our thoughts tonight. At its closest approaches, the Parker Solar Probe travels faster than any object humans have ever built, hundreds of kilometers per second, fast enough that the distance from one city to another vanishes in moments. The probe is protected by a carbon composite heat shield just over 11 centimeters thick. On the sun-facing side of that shield, temperatures reach close to 1500 degrees Celsius. On the other side, the instruments sit in room temperature shadow, collecting data quietly. 11 centimeters of carbon between human instruments and the corona of a star. There is something almost tender about that image. All of our curiosity about the sun, everything we want to understand about the thing that has warmed every morning of every human life, being carried toward it in a small machine protected by a layer of material thinner than your forearm, going to meet the sun, gently, on our behalf. Once a year, the sun appears to pause. It does not actually stop. The word solstice comes from the Latin for sun and to stand still. And for a brief period around the 21st of June and the 21st of December each year, the sun reaches its highest or lowest point in the sky and seems, from Earth, to halt before reversing its direction. This is a product of Earth's axial tilt. As Earth orbits the sun, our 23-degree lean means that different hemispheres receive different amounts of light at different times of year. At the solstices, that tilt is directed most fully toward or away from the sun, and the change in the sun's apparent path slows to its minimum. It lingers, then it turns. Ancient peoples across the world marked the solstices with architecture, ceremony, and attention. Newgrange in Ireland, Stonehenge in England, the temples of Chichen Itza in Mexico, all aligned to catch the precise angle of solstice light. Built before writing, before metal tools in many cases, using only patience, observation, and stone. The sun pausing was important enough to build mountains for, to orient an entire culture around, to pass down through generations as the most important moment of the year. We have not lost that knowing. We have only forgotten how deliberate it once was. Seasons are a conversation. not between the sun and Earth exactly, but between the sun and the way Earth holds itself. The 23-degree tilt of Earth's axis is the reason summer exists, the reason winter exists, the reason that the same sun can feel like a different star depending on where you stand in the year. The tilt determines how directly sunlight strikes the ground, how long the days run, how much warmth accumulates before the nights take it back. Without the tilt, every day of the year would feel the same at every latitude. There would be no summer evenings that seem to last forever, no winter afternoons that darken before you are ready, no autumn light, which is its own particular quality of gold that people have been trying to describe accurately for as long as people have been writing things down. The tilt is not a flaw in Earth's design. It is the source of almost everything we find beautiful about the year. The seasons are what happens when a planet refuses to stand up straight. And the sun does not cause the seasons by being closer or farther away. Earth is actually slightly closer to the sun in January than in July. The seasons are entirely about angle, about how directly the light arrives, about whether you are leaning toward the warmth or gently away from it. Even the sun's generosity is shaped by how you receive it. The auroras are a conversation too. They begin with the sun. With the solar wind we have already met tonight, that constant outpouring of charged particles streaming outward from the sun in every direction. Those particles travel across space and eventually reach Earth, where our planet's magnetic field is waiting. The magnetic field does not stop the solar wind. It redirects it. It guides the charged particles along invisible lines of force toward the poles, where the field dips closest to the surface. There, at the top and bottom of the world, the particles collide with molecules in the upper atmosphere. Those collisions release energy as light. Oxygen glows green and red. Nitrogen glows blue and purple. The colors depend on which molecules are struck, and at what altitude, and with how much energy. The result is the aurora borealis in the north and the aurora australis in the south. Curtains of living light, shifting and folding, moving with the invisible architecture of Earth's magnetic field. People have stood beneath auroras for as long as people have existed in high latitudes. They have told stories about them. They have felt, correctly, that something was happening at the boundary between Earth and something larger. The auroras are the visible seam where your planet and your star touch, and they are, by any measure, one of the most quietly extraordinary things you can stand beneath. Sunflowers know something we had to learn. For years, people assumed that sunflowers tracked the sun across the sky throughout their lives, turning their faces from east to west each day in continuous devotion. It is a beautiful image. It is also only partially true. Young sunflowers do track the sunday. Their stems grow faster on the shaded side during the day, bending the flower toward the light, then reverse at night, resetting for the next morning. This movement is driven by circadian rhythms in the plant's growth hormones, and it is real and measurable. But adult sunflowers stop. Once a sunflower matures, it faces east and stays there, fixed. It warms itself in the morning sun, which attracts more pollinators because warm flowers are preferred by bees. It stops chasing what it once chased and simply settles into the position that serves it best. Scientists confirmed this fairly recently, watching fields of sunflowers carefully over many days and nights. The young ones moved, the mature ones did not. There is something in that worth sitting with quietly. The young thing reaches and turns and follows. The mature thing finds its orientation and rests in it, facing the morning, still, not because it has given up, but because it has learned which direction the warmth comes from, and decided that is enough. The sun's gravity reaches the edge of everything we have sent into space. The Voyager probes were launched in 1977, carried outward by the gravity of the outer planets, and have been traveling away from the Sun ever since, at speeds that would cross a continent in seconds. They are the most distant human-made objects in existence, and only now, after nearly 50 years of travel, are they crossing the heliopause, the boundary where the Sun's wind finally gives way to the interstellar medium. Everything inside that boundary is, in a technical and real sense, still inside the Sun's sphere of influence, still within the heliosphere, still, however faintly, touched by the same star whose light is warming a window somewhere near you right now. The heliosphere is so large that even traveling at the Voyager's speed, it has taken half a century to approach its edge. Light from the Sun takes over 16 hours to reach the heliopause. 16 hours of travel at 300,000 kilometers per second, and yet the Sun holds all of it, quietly, without effort, the way very large, very old things hold the things around them, not through force exactly, but through the simple, patient fact of their presence. You are held tonight by the same gravity that holds the Voyagers, the same reach, just much, much closer to the center of it. Time runs differently near the Sunday, not as a metaphor, not as a feeling, as a measurable, verified physical fact. Gravity curves space-time, and the Sun's gravity is substantial. A clock placed on the surface of the Sun, if such a thing were possible, would tick more slowly than a clock held in your hand, not by much, by the standards of daily life, but by enough to measure, by enough that it must be accounted for in precise calculations, the way it must be accounted for in the satellites that tell you where you are on Earth. This is general relativity, Einstein's description of how mass shapes the fabric of space-time around it. The Sun is the most massive object in the solar system, and its curvature of space-time is the largest local distortion we live inside. We confirmed this in 1919, during a total solar eclipse, when Arthur Eddington measured the positions of stars near the Sun's edge and found them slightly displaced from where they should have been. The Sun's gravity was bending their light. Einstein was right. Space itself curves around a star. So even the geometry of the sky is shaped by the Sunday. The straight lines light travels are only straight until they pass close enough to something heavy enough to remind them otherwise. The universe is not flat, and the thing reminding you of that every day is the same thing warming your morning. The Sun does not spin the way a ball spins. A ball, a planet, a moon, any solid object rotates as one piece. Every part of it completes one rotation in the same amount of time. The equator and the poles move together, locked into a single rigid period. The Sun is not solid. It is plasma throughout, fluid and free, and its different latitudes rotate at different speeds. The equator completes a rotation in roughly 25 days. The poles take closer to 35. The surface of the Sun is not turning as one thing. It is turning as many things, each latitude finding its own pace, the whole sphere shearing gently against itself in a continuous, slow differential rotation. This differential rotation is part of what drives the Sun's magnetic field into the complex, twisted, dynamic state that produces sunspots and flares and the 11-year solar cycle. The field lines get wound up over time, stretched and tangled by the shearing of plasma moving at different speeds, until they break through the surface in concentrated bursts. The Sun is a sphere that cannot decide how fast to turn, and that indecision, that internal tension, is responsible for almost everything dynamic we observe in it. Even the Sun's inconsistency is generative. Even what it cannot resolve becomes something that lights the sky. When the Sun sets, it is already gone. Not dramatically, not in a way that matters for most purposes, but precisely, physically, verifiably. By the time you see the sun touch the horizon, the actual sun has already moved below it. What you are seeing is a ghost of the sun, a refracted image, bent upward by the atmosphere into your line of sight for a few extra minutes, beyond where the sun actually sits. The atmosphere acts as a lens at low angles, bending light around the curve of the Earth and extending the visible day by a few minutes beyond what geometry alone would allow. The red and orange colors of sunset are partly this refraction at work, the same mechanism that scatters blue light away and leaves only the longer wavelengths to travel the extended path to your eye. So sunset is already a kind of memory. You are watching the sun's image linger after the sun itself has moved on. The sky holds the light a little longer than the source deserves. There is something tender in that. The atmosphere, without any intention, without any design, gives you a few more minutes of the sun than physics strictly allows. A small gift of refraction, an accidental extension of the day. The world holds the light a little longer than it has to, and you are welcome to stay in it. Right now, passing through your thumbnail, there are billions of neutrinos, every second, without pause, without any sensation on your part whatsoever. Neutrinos are produced in enormous quantities by the fusion reactions in the sun's core, and they travel outward through the sun itself, almost without interacting with anything, through the entire body of the star, out into space, across the distance to Earth, through the atmosphere, through the ground, through you. They pass through the Earth as if the Earth were not there. The entire planet is essentially transparent to them. A neutrino traveling straight down through your body would need a wall of lead roughly a light year thick to have a better than even chance of being stopped. This sounds strange. It is strange. But it also means something quiet and remarkable. You are being touched, in a sense, by the sun's core right now, not by its surface light, which takes 100,000 years to escape the interior, by the fusion happening at this moment, at this second, in the deepest part of the star. Neutrinos carry news from the center, and they arrive almost instantly. The light of the sun is ancient, but the neutrinos are fresh, and they are moving through you, quietly, even as you rest. Once, a storm on the sun interrupted a kitchen, not in any catastrophic way, not with any violence that reached the ground. But in 1989, a particularly powerful solar flare sent a wave of charged particles toward Earth that overwhelmed power grids in Quebec, leaving 6 million people without electricity for hours. And in smaller, quieter ways, solar activity has been disrupting radio signals, compass readings, and satellite communications for as long as we have had instruments sensitive enough to notice. A solar flare is a sudden, intense release of energy from the sun's surface, driven by the same magnetic dynamics we have been tracing tonight. The largest ones can release energy equivalent to billions of nuclear weapons, though that comparison is almost meaningless at that scale, and more useful as a way of gesturing at something genuinely vast. What it means practically is this: a storm happening 150 million kilometers away can cause static in your radio. It can shift the needle of a compass by a measurable degree. It can interrupt a satellite phone call or confuse an aeroplane's navigation system for a few minutes. The sun is so present, even at that distance, that its weather becomes our weather. Its disturbances ripple all the way to the surface of a small, quiet planet and announce themselves in the most ordinary interruptions. Even from that far away, it is still close enough to make itself known in your kitchen. The moon is the sun at night, not its own light, never its own light. The moon produces nothing. It simply receives what the sun sends and returns some fraction of it back into space. What you see when you look at a full moon is sunlight that has crossed 150 million kilometers, struck the lunar surface, and bounced back to your eye across another 380,000 kilometers of space. The moon reflects only about 12% of the sunlight that hits it. It is, by the standards of reflective surfaces, quite dark, roughly as reflective as worn asphalt. And yet at full moon it is bright enough to read by, bright enough to cast shadows, bright enough that people have navigated oceans by it for thousands of years. That is what 12% of the sun looks like, softened by 250,000 miles of additional travel, and it is enough to light the night, enough to make the dark navigable, enough to have been the most important light in every human life for almost all of human history, until very recently. Every full moon you have ever stood under was the sun, wearing stone, quieter, cooler, made gentle by distance and reflection, but still, underneath, the same ancient light that warms your mornings. The night has never been entirely without the Sunday. A leaf is a solar panel, a very old one, refined over hundreds of millions of years of evolution into something so elegant and so efficient at its particular task that human engineers have spent decades trying to understand it well enough to replicate it and still cannot match it at the level of the individual molecule. Photosynthesis is the process by which plants, algae, and some bacteria capture sunlight and use its energy to convert carbon dioxide and water into sugar. The sugar feeds the plant. The oxygen is released as a byproduct. Every breath of oxygen you take is the exhaled waste of photosynthesis, accumulated over billions of years of plants and algae doing their quiet work in sunlight. The machinery inside a leaf that does this is called a chloroplast, and inside the chloroplast are structures called thylakoids, stacked like coins, containing chlorophyll molecules, arranged with a precision that allows them to capture individual photons of light and funnel their energy into chemical reactions. A single leaf, on an ordinary afternoon, is doing something that Nobel Prize winners are still working to fully understand. It is turning a star into sugar. It is feeding itself on light. Every green thing you have ever seen was a record of the sun, written in living matter. Every salad, every forest, every blade of grass in a lawn is sunlight that has been caught and held in a form you can touch. Below the sun's visible surface, something we cannot see directly is happening. The photosphere, the layer we observe when we look at the sun, is only the outermost boundary of a much deeper and stranger interior. Below it lies the convection zone, where hot plasma rises and cooler plasma sinks in vast, slow currents, carrying energy outward from the interior. Below that lies the radiative zone, where energy moves not by convection, but by being absorbed and re-emitted, in that long, stuttering journey we visited earlier tonight. And at the center lies the core, where fusion actually happens. None of these layers can be seen directly. No light escapes from the interior. The photons we receive all originate at or near the surface. Everything below is inferred, modeled, deduced from the behavior of the surface and from helioseismology, from listening to the sun vibrate and working backward to what must be happening inside. We know the interior of the sun, the way a doctor might know the interior of a body without surgery, by listening to it, by measuring how it moves, by understanding what the surface behavior requires the interior to be doing to produce it. The sun is, in this sense, opaque to us. We live in its light and cannot see inside it. We are warmed by an interior we have never witnessed directly, and never will. Some warmth comes from places we are not permitted to see, and it is no less real for that. In the deep ocean, there are creatures that have never seen the Sunday. They live around hydrothermal vents, fractures in the ocean floor where geothermally heated water emerges, rich in minerals. The communities clustered around these vents, tube worms, vent crabs, chemosynthetic bacteria, do not depend on sunlight at all. They are powered by the chemistry of the Earth's interior, not by the star above. And yet, in the deepest sense, they are still solar. The heat driving those vents originates partly from the decay of radioactive elements left over from the formation of the solar system, the same cloud of gas and dust that became the Sunday. The ocean itself was delivered to Earth partly by comets and asteroids that formed in the solar nebula. The elements in every living thing at those vents were forged in stars. Life without sunlight is still life shaped by the history of a star. The influence simply went underground, went deep, went quiet. Even in the darkest places on Earth, in the places farthest from the sun's direct light, the story of a star is still being told, just in a different language, just at a different depth. The sun's reach is not only the reach of its light, it is the reach of everything it set in motion 4.5 billion years ago when it first began to burn. The sun was born from silence, not quite silence, but from something so diffuse and cold and still that it might as well have been a nebula, a vast cloud of gas and dust drifting in the galaxy, largely hydrogen, laced with traces of heavier elements left by previous generations of stars. For perhaps billions of years it simply existed, moving slowly through the galaxy, disturbed by almost nothing. Then something changed. Perhaps a nearby supernova sent a shockwave through the cloud. Perhaps gravitational instabilities within the cloud itself reached a tipping point. Whatever the cause, parts of the cloud began to collapse inward under their own gravity. As they collapsed, they heated. As they heated, they began to rotate faster, conservation of angular momentum spinning the collapsing gas into a disk. At the center of the disk, pressure and temperature climbed. Over millions of years, they climbed until hydrogen began to fuse, and the sun ignited. It did not announce itself. It did not arrive with ceremony. It simply reached the conditions required and began, a star becoming itself in a cloud of its own making. Everything in the solar system, every planet and moon and comet and asteroid, every element in your body and in the air you are breathing right now, came from that same collapsing cloud. The sun did not form in isolation. It formed as part of a family. You are part of what was left over when a star was born. You were there, in a sense, at the beginning. Even as you rest right now, you are moving. Not in any way you can feel, not in any way that requires effort or even awareness. But Earth is carrying you around the sun at approximately 30 kilometers per second. In the time it takes to read this sentence, you have traveled several hundred kilometers through space. In the time you have been lying still tonight, you have covered a distance that would take years to drive. This motion is so smooth, so perfectly maintained, so free of any friction or resistance in the vacuum of space, that you feel none of it. There is no wind. There is no sense of acceleration. There is only stillness, from your perspective, while the universe arranges itself around you at tremendous speed. And the sun is the reason. Its gravity is the string that keeps Earth in its loop. Without it, Earth would travel in a straight line outward into the dark, following the path all moving objects follow when nothing pulls them. The sun's gravity is the gentle, constant tug that bends that straight line into a curve. and the curve into a circle, and the circle into a year. Rest is always relative. You are still, and you are flying. Both are true at the same time tonight. The sun is holding you in your orbit, even as it lets you feel perfectly, completely at rest. When the sun sets on one side of the world, it rises on the other. This is so obvious it barely seems worth saying. And yet, held quietly for a moment, it opens into something larger. There is never a time when the sun is not rising somewhere on Earth. Never a moment when some part of this planet is not moving into morning, into the particular quality of light that comes just before and just after sunrise. That horizontal gold that makes everything look like it is being seen for the first time. Right now, as you drift towards sleep, someone is standing in that light. Someone is watching the sky pale from black to deep blue, to the first suggestion of color at the horizon. Someone is hearing the first birds. Someone is feeling the air begin to warm against their face after the long cool of the night. The sunrise that belongs to them is the same sun that set for you, or will rise for you. The sun does not pick its favorites. It simply turns with the earth, illuminating whatever is presented to it, warming whatever leans into its light. You are sharing a star with everyone alive right now. Not abstractly, actually. The same photons, the same fusion, the same ancient steady burning, passed around the planet as it turns, offered to each face in turn. The sun rises for everyone. It has always risen for everyone. It will go on rising long after the last of us has gone to sleep. Billions of messengers from the sun's core are passing through you right now. Not from its surface, not from the light we see and feel, from the core itself, from the fusion happening at this very second, in the deepest and most unreachable part of the star. Neutrinos, produced in the heart of every fusion reaction, travel outward through the sun's body, almost without interacting with anything at all, and cross the distance to Earth in just over 8 minutes. They pass through the Earth as though it were made of nothing. Through rock, through water, through every living and unliving thing on the surface. Through you, right now, in their billions, every second, without leaving any trace you could ever feel. A detector built to catch them, buried deep underground to shield it from other particles, might register a handful in a day. The rest simply continue outward into space, carrying news of the sun's interior to places we will never reach. This is, in its quiet way, one of the most remarkable things happening to your body at this moment. You are being interpenetrated by the sun's innermost processes, not its surface warmth, not its ancient light, but its present tense fusion, arriving fresh, passing through, continuing on. The sun is not only something out there, it is, in a very literal sense, passing through you as you rest. You and the star are, for this moment and every moment, briefly and continuously the same space. The same sunlight warms every shore at once. Right now, as you settle towards sleep, the sun's light is falling on a snowfield somewhere in Norway, on the limestone coast of a Greek island, on red desert sand in the interior of Australia, on the surface of the Pacific Ocean, on a rice paddy in Vietnam, on a city roof in Brazil. All at once, all from the same source, all the same photons, born from the same fusion, differentiated only by what surface they happen to land on, and what that surface does with them. The snow reflects most of what arrives. The ocean absorbs it slowly, warming the upper layers. The desert receives it intensely and radiates it back as heat by evening. The rice paddy turns it into food, each surface in conversation with the same light, doing something different with what it receives. And none of it belongs to any particular place. The sun does not send its light to Norway or to Vietnam. It sends it everywhere, indiscriminately, abundantly, and each place simply takes what the geometry of the Earth's rotation brings it. You live in a world where every surface, every person, every creature is being illuminated by the same source. Not the same amount, not at the same angle, not at the same moment, but the same origin, the same star, the same morning light that will find you tomorrow is finding someone else right now, and neither of you is more the intended recipient than the other. Somewhere above you, the sun's corona is burning at millions of degrees, and below it, touching the visible surface, temperatures drop to thousands of degrees, and that reversal, heat increasing with distance from the source, remains one of the genuinely open questions in solar science. We have visited this mystery briefly before tonight, but it deserves a moment of its own in the quiet. The corona has been known to be hot since the 1940s, when astronomers identified spectral lines in its light that could only be produced at temperatures far beyond what the surface showed. For decades, the leading explanation involved waves, alpha waves, specifically a type of wave that propagates along magnetic field lines and can carry energy from the surface into the corona, depositing it as heat. More recently, the Parker Solar Probe has observed these waves directly, confirming they exist and carry significant energy. But whether they alone account for the full temperature of the corona is still debated. There may be additional mechanisms. Small magnetic reconnection events, called nanoflares, may contribute. The full answer may require both, and possibly something we have not yet identified. The sun has been studied longer than any other star. It is the subject of more dedicated observatories, more satellite missions, more scientific attention than anything else in the sky. And this question, why is the corona so hot, remains genuinely, honestly open. The closest star keeps its secrets patiently, and the secrets, when they are eventually told, will very likely be beautiful. A total solar eclipse is an accident of geometry, not designed, not inevitable. The moon happens to be about 400 times smaller than the sun, and the sun happens to be about 400 times farther away. These two ratios cancel each other out almost perfectly, which is why the moon and the sun appear almost exactly the same size in Earth's sky, close enough that during a total eclipse, the moon covers the sun's disk almost perfectly, revealing the corona, the outermost atmosphere, which is otherwise invisible against the sun's brilliance. This coincidence has no known cause. It is not required by any physical law. It is simply the result of how far away the moon formed and how far away the sun sits. On Mars, the moons are too small to create a total eclipse. On Jupiter, there are no moons in the right position. Earth is, as far as we know, the only planet in the solar system where a moon covers its star so precisely that the star's atmosphere becomes briefly visible from the surface. And the window is closing. The moon is slowly moving away from Earth, about 4 centimeters per year. In the very distant future, it will be too small and too far to cover the sun completely. Total solar eclipses will no longer be possible. We are living in the era when they still are. We are living in the particular geological moment when the geometry happens to work. When the sky offers this gift, it is worth going to see it. Even your sleep is the sun's doing, not metaphorically, physiologically. The hormone melatonin, which signals the body to prepare for sleep, is suppressed by light and released in darkness. As the sun sets and light fades from the sky, the brain's pineal gland detects the change and begins releasing melatonin into the bloodstream. The body temperature drops slightly. the heart rate slows. The whole system begins its long, careful preparation for rest. This mechanism evolved over hundreds of millions of years, calibrated to the rhythm of a rotating planet and its star. The body clock, the circadian rhythm, runs on roughly a 24-hour cycle because the Earth rotates on roughly a 24-hour cycle. The two have been in conversation for so long that the cycle is now written into the biology of almost every living thing on Earth. When you feel sleepy at the end of a day, you are feeling the sun's absence. When you feel alert in the morning light, you are feeling its return. The star that warms your skin during the day is also, through its setting, sending you to sleep at night. Your rest tonight is not separate from the Sunday, it is the sun's gift, arriving in its absence. The darkness that lets you sleep is simply the space the sun leaves when it moves on, and your body has been waiting for that space, faithfully, every evening of your life. A photon has extraordinary patience. It is born in the sun's core, in the moment of a fusion reaction, and immediately begins a journey that will take far longer than any human civilization has existed. The core is so dense, so packed with plasma and charged particles, that the photon travels only a tiny distance before being absorbed by an ion. Then it is re-emitted in a random direction, then absorbed again, then re-emitted again, in another random direction, with no memory of where it came from or where it is going. This process, called a random walk, is so inefficient that the photon's net progress outward is agonizingly slow. The numbers are difficult to hold. It may take between 10,000 and 100,000 years to travel from the core to the surface. The same distance that light, traveling freely, would cross in about 2 seconds. Then it reaches the surface, and it is released. And it crosses 150 million kilometers of open space in 8 minutes and 20 seconds. And then it lands on something, perhaps a leaf, perhaps a solar panel, perhaps the back of your hand, on an afternoon when you stepped outside and tilted your face toward the sky, without quite knowing why. That photon waited 100,000 years inside the Sunday, and then it crossed space in 8 minutes, and then it found you. The universe takes its time, but it arrives. Every shadow you cast is a small, unrepeatable record. The particular angle of your shadow at any given moment depends on the time of day, the time of year, your latitude, the terrain around you, even the weather. The exact length and direction of your shadow at 3 in the afternoon on a Tuesday in April has never existed before and will never exist again in quite that combination. Ancient peoples used shadows deliberately. The gnomon, the upright pin of a sundial, is one of the oldest scientific instruments in human history. By watching where the shadow fell and how it moved, people tracked hours, seasons, the approach of solstices and equinoxes. The shadow was a clock. It was a calendar. It was a record of where you stood in relation to a star. Your shadow is still that. It is still a record of your position in relation to the sun, rendered briefly on whatever surface is beneath you, then erased as the earth turns and the light shifts. It exists for a moment, and then it is gone. It is not saved anywhere. It is simply released back into the light that made it. You carry a daily record of your relationship to a star. It follows you. It shortens and lengthens with the hours. It is always pointing away from the same source. And every evening, without ceremony, it simply fades, and the star and you are even again. Even when you cannot see the sun, it is holding you. Not poetically, gravitationally. The sun's gravitational field does not switch off at night. It does not weaken because clouds have moved in or because the earth has turned your particular patch of ground away from the light. Gravity propagates across the solar system continuously, at the speed of light, and the sun's pull on the Earth is as present at midnight as it is at noon. You are in orbit right now, not drifting, not moving in a straight line outward into the dark. You are held in a curve, a loop, a gentle, endless arc that has been carrying this planet around the same star for 4.5 billion years without interruption. The darkness of night is not absence. It is simply the other side of the orbit, the half of the rotation where your face is turned away from the light, while the gravity that keeps you on the path continues exactly as before, patient and complete, and entirely indifferent to whether you can see the source of it. When you wake tomorrow and the light returns, the sun will not have come back. It will have been there the whole time. You will simply be facing it again. The sun is not something that arrives in the morning and leaves at night. It is something you orbit, something you return to every day, as reliably as the physics of the solar system allows, which is to say, as reliably as anything has ever been. Gravity does not ask permission. It does not require your awareness, your attention, or your gratitude. The sun's gravitational reach extends so far into the solar system that even the most distant comets, wandering objects that spend most of their lives in the cold dark beyond Neptune, are still loosely bound to it. They belong to the sun, the way a very long pendulum belongs to its anchor, barely, slowly, but genuinely. The Oort cloud, a vast spherical shell of icy bodies believed to surround the solar system at enormous distances, is thought to be held by the sun's gravity at a range of perhaps a quarter of the distance to the nearest other star. These objects move so slowly and so far away that a single orbit might take millions of years. They have companions they will never meet. They travel paths so long that the sun, from that distance, would appear as nothing more than a very bright star among other stars. And still they are held. Still they belong, in the loose and ancient sense, to this solar system. Still the sun's gravity, faint as a whisper at that range, is enough to keep them from drifting entirely away. You are never in darkness deep enough that the sun has let go. Even at the farthest reach of what this star governs, the thread remains, tenuous, patient, old, beyond calculation. The sun holds more than you can see. It always has. Learning that the sun was a star like other stars was not a small discovery. For most of human history, the sun was a category unto itself. It was the light, the warmth, the source of life, the object of reverence, the center of the sky. The stars were something else entirely. Cold, small, distant, decorative. The lights of night were not thought to be the same nature as the fire of day. The idea that they were the same thing, that the sun was simply a star seen from close up, and that the stars were simply suns seen from very far away, was not widely accepted until the 19th century, when measurements of stellar distances and brightness made the comparison unavoidable. Our sun was, by the standards of the galaxy, ordinary, a middle-sized, middle-aged, middle-brightness star among hundreds of billions. This did not make the sun smaller, it made the night sky warmer. Every point of light you have ever seen on a clear night is a sun, some larger, some smaller, some hotter, some older, but all of them, in principle, doing what our sun does, burning, shining, holding, some of them with planets, some of those planets possibly with something looking up. The sky did not shrink when we understood this. It expanded into something populated, into something that felt, for the first time, less like a ceiling and more like a neighborhood. Your eyelids glow, not brightly, not in any way visible to anyone looking at you. But if you have ever rested in afternoon light with your eyes closed, you have noticed the deep, warm orange that fills your vision. That is sunlight passing through your eyelids, through the thin skin, through the blood vessels beneath, the red of the blood filtering the light and giving it that particular warm color of something seen through living tissue. Your eyelids are thin enough, and your blood vessels close enough to the surface, that sunlight is partially transmitted rather than fully blocked. What reaches the retina through closed lids is reduced and reddened, enough to tell the eye that there is light, not enough to form any image. This is one of the quietest and most intimate ways the sun touches you. Not on the face, not on the arm, not on any exposed skin, through closed eyes, through skin, through the interior of your own body. Even when you close your eyes against the sun, you still receive it. You still glow, faintly, from the inside, with borrowed light. There is something in that worth resting in. The sun finds its way through even the simplest barrier you put between yourself and it. Not insistently, just persistently, just warmly, just enough to remind you, through closed eyes, on a quiet afternoon, that the star is still there. The sun will not end violently. This is worth knowing. The popular image of a star dying tends toward drama, explosions, supernovae, the spectacular collapse of something massive into a neutron star or a black hole. These things happen. They are real. But they happen to stars much more massive than our Sunday. Our sun will end quietly, as it exhausts its hydrogen fuel over the next 5 billion years. It will begin to expand into a red giant, growing large enough to engulf the inner planets. But this expansion is slow, gradual, measured in millions of years, not moments. And when the outer layers drift away into space, what will remain is the core, a white dwarf, a dense, slowly cooling ember roughly the size of Earth. A white dwarf does not stop, it simply dims. It radiates the heat of its formation into space over trillions of years, cooling from white to yellow to orange to red to something dark and cold that has no common name yet, because no white dwarf in the universe has had time to reach it. The universe is not old enough. So the sun will become something small and persistent, and very slowly quieting. It will not announce its ending. It will simply continue, more slowly and more dimly, for longer than we can meaningfully picture. Even in dying, the sun will be patient. Even then, it will simply be continuing what it has always done. Even now, your body is catching up with the afternoon. The sunlight that reached your skin during the day set off a chain of processes that are still running as you rest. Vitamin D synthesis, triggered by ultraviolet light on the skin, does not complete in the moment of exposure. The precursors are made in the skin and then converted further in the liver and kidneys over hours. The sunlight you received this afternoon is still being processed, still being transformed into something your body can use, right now, as you lie still. This is one of the quieter ways the sun travels with you through the day and into the evening, not just as warmth or light in the moment of exposure, but as a process that continues after the source has set. Your body holds onto the conversation longer than the conversation technically lasts. The same is true of your mood, in subtler ways. Light exposure during the day influences serotonin production, which in turn influences melatonin levels at night, which shapes the quality of your sleep, which shapes how you feel tomorrow morning. The chain is long and indirect, but it is real. Today's sunlight is part of the reason you will wake the way you wake tomorrow. You carry the day's light into the night with you, not as memory exactly, as biology, as a quiet, ongoing conversation between your body and a star. The sun breathes in 11-year cycles, not literally, but the metaphor is close enough to the physics that it is worth holding. Every 11 years, the sun moves through a cycle of increasing and decreasing magnetic activity, from solar minimum, when the surface is relatively calm and sunspot numbers are low, to solar maximum, when activity peaks and sunspots, flares, and coronal mass ejections are most frequent, and back again. This cycle was first noticed in the 1840s by the German astronomer Samuel Heinrich Schwabe, who spent 17 years counting sunspots before recognizing the pattern, 17 years of daily observation, before the rhythm became clear. At solar minimum, the sun looks quieter. At solar maximum, its surface is more turbulent, its magnetic field more tangled, its output of charged particles more intense. Auroras are more frequent and more vivid near solar maximum. Radio disruptions are more common. The upper atmosphere swells slightly as it absorbs more energy. We are, right now, in a particular phase of a particular solar cycle. The sun is doing something specific and measurable tonight, somewhere on its 11-year breath. Scientists are watching it, instruments trained on the surface and the corona, tracking the cycle the way you might track the seasons. The sun has rhythms within rhythms, cycles within cycles, and underneath all of them, the same steady fusion, the same patient burning, the same warmth arriving at your window every morning, without fail. The idea that the sun is a star was once genuinely radical, not just unfamiliar, actively dangerous to assert. Giordano Bruno, the 16th century philosopher, proposed, among other things, that the stars were distant suns, each possibly surrounded by inhabited worlds. He was burned at the stake in 1600, though his cosmological views were only part of what condemned him. The question of whether the sun was one star among many, or a unique object, was not merely scientific. It was theological. It was political. It was a question about the structure of reality and the place of humanity within it, and the answers carried enormous social weight. What is remarkable is not that people resisted the idea. What is remarkable is that eventually, through observation and measurement and the slow accumulation of evidence, the idea won. Not because anyone decided to accept it, but because the evidence became impossible to arrange into any other shape. The sun is a star. Our sky has a sun in it. The night sky is full of skies. Each of those skies, potentially, has someone in it looking up. That is the thought that was once dangerous enough to kill for, and now it is something you can simply rest inside, quietly, as one of the most ordinary and extraordinary things you know. The sun will outlive every mountain, not just some mountains. Every mountain range currently standing on Earth will have eroded to plains long before the sun enters its red giant phase. The Himalayas, the Andes, the Rockies, the Alps, all of them temporary. All of them brief wrinkles in the crust of a planet that is itself brief by the sun's reckoning. Mountains feel permanent to us because they outlast everything in human experience. They are the symbol of permanence in almost every culture that has them. Immovable, eternal, beyond change. And yet the sun will watch them come and go. It has already watched mountain ranges rise and erode that we have no record of, that left no trace in any story. Ranges that were as tall as the Himalayas, as vast as anything currently standing, now ground to sediment at the bottoms of ancient seas. The sun noticed none of this. It simply continued. It will simply continue. There is nothing frightening in that. The sun's patience is not indifference. It is simply a different scale of time, operating alongside the human scale without conflict. Mountains rise and fall. The sun persists. You rest for a night. All of these things are true simultaneously, each at its own pace, each complete within its own duration. Permanence is not required for something to matter. You matter at your scale. The mountains matter at theirs. And the sun persists through all of it, generously, without keeping score. Once, recognizing the sun as a star felt like a loss. Some people experienced it that way. The sun had been singular, sacred, the center of everything, not just physically but spiritually, the source of light and life and meaning, the eye of the sky, the God that most human cultures had, in one form or another, reached toward. To learn that it was simply one star among hundreds of billions felt, to some, like a demotion, a shrinking, a replacement of something warm and personal with something cold and statistical. But something else happened too, quietly, for those who stayed with the thought long enough. The night sky changed, not its appearance, its feeling. Every point of light became a sun. Every sun became a possible center. Every possible center became a possible warmth, a possible morning, a possible world turning slowly in the light of something steady and middle-aged and unremarkable. The sky did not become less. It became more populated, more various, more full of the particular kind of meaning that comes not from uniqueness but from recognition, from seeing yourself, or something like yourself, repeated across a distance so vast it has no useful comparison. Your sun is one of hundreds of billions of stars in this galaxy alone, and that fact, held gently rather than quickly, does not make the warmth on your face less warm. It makes the warmth more remarkable, because it means the warmth is not an accident of a singular object. It is a property of the universe itself. The universe makes suns. It makes them abundantly, and one of them, by the grace of orbital mechanics and geological time, is yours. Every sunrise you will ever see has already begun. Somewhere on Earth, right now, in a time zone you may never visit, in a language you may not speak, someone is watching the sky go from black to deep blue, to the first pale suggestion of something warmer at the horizon. The birds are beginning. The air is just starting to carry the faint warmth that distinguishes early morning from true night. And the sun is arriving, as it has arrived every morning for 4.5 billion years, without announcement, without drama, without any particular care for whether anyone is watching. But someone usually is. Across all of human history, the sunrise has been witnessed by farmers checking the sky before a day in the fields, by sailors reading the horizon for weather, by children who woke too early and could not sleep, by people sitting with something difficult and finding, in the simple return of light, a kind of company. The sunrise has never gone unwatched, not because someone planned it that way, but because humans have always been here, and have always, in their millions and billions across all of history, included some number of people awake at the moment the light returned. Right now, someone is watching the sunrise. Right now, across the curve of this planet you share with 8 billion others, the light is returning to someone, and what they feel, standing in it, is not so different from what you would feel. The sun rises for everyone. It always has, and the watching of it connects you, quietly, to every human who has ever stood in early light and simply been glad it came back. The sun is quiet, by stellar standards. This is not a poetic softening. It is an astronomical classification. Our sun is a G-type main sequence star, sometimes called a yellow dwarf, though it appears white from space and only looks yellow or gold through the atmosphere. G-type stars are, by the standards of the stellar population, calm, long-lived, and stable. They do not flare violently as often as smaller, cooler M-dwarf stars. They do not end in supernovae, as larger O and B stars do. They simply burn, steadily, for approximately 10 billion years, and then they change. When scientists search for planets that might support life, they pay close attention to the type of star those planets orbit. A star that flares frequently and violently makes life difficult, bathing nearby planets in radiation that can strip away atmospheres. A star that is too short-lived does not give life enough time to develop complexity. A G-type star, quiet and consistent over billions of years, is considered one of the more promising environments. You orbit a promising star, not the most spectacular, not the brightest or the largest or the most energetic, but one of the steady ones, one of the patient ones, one of the stars that keeps the lights on without drama for long enough that something extraordinary can happen on a nearby planet. Quietness, it turns out, is a gift. Steadiness is what made you possible. The most important thing your sun ever did was simply continue. Right now, your body is breathing sunlight. Not directly, not in this moment, but in the most literal chemical sense, you are. The oxygen in your lungs right now was produced by photosynthesis, by plants and algae and ancient bacteria that captured sunlight, split water molecules, and released oxygen as a byproduct. The atmosphere itself, the specific mixture of gases that makes Earth breathable, is a product of billions of years of photosynthesis conducted in sunlight. Before photosynthetic life emerged, Earth's atmosphere contained very little free oxygen. It was the sun, working through living things over billions of years, that changed that. That oxygenated the air. That made it possible for complex, oxygen-breathing life to exist at all. So when you breathe in right now, you are receiving the accumulated work of every photosynthetic organism that has ever lived in sunlight on this planet. You are breathing the output of 4 billion years of solar energy, captured and transformed and released into the air by organisms ranging from microscopic ocean algae to the largest forests that have ever grown. Your breath is the sun's work, passed through time, through biology, through the long, patient chemistry of a living planet. You inhale and the sun is there, in the oxygen, in the particular composition of air that your lungs were built to receive. Even now, in the dark, in the quiet, breathing slowly towards sleep, you are still in conversation with a star. The word day contains the Sunday, not in any language you could point to easily, but etymologically, in the deep history of the words humans use for light and time, the connection between day and the sun is older than writing. In Proto-Indo-European, the reconstructed ancestral language from which most European and many Asian languages descend, words for day and for the sky and for the shining were bound together in roots that appear transformed but recognizable in dozens of modern languages. The word deity in English traces back to the same root as the word day. Deus in Latin, Zeus in Greek, Daios in Sanskrit, all of them connected, in the deepest layer of linguistic archaeology, to the sky, to light, to the shining of the Sunday. This means that when humans first began to attach the concept of the divine to a word, the word they reached for was already the word for daylight. The sacred and the solar were not just associated in ritual or myth, they were fused at the level of language itself, before the languages we recognize had fully formed. You carry this in your vocabulary without knowing it. Every time you name the time between dawn and dusk, you are using a word that, in its oldest form, meant the shining of the sky. The sun is embedded in your language the way it is embedded in your biology. Quietly, completely, From the beginning, ancient people built mountains for the Sunday. Not metaphorically. They moved stone. Enormous quantities of stone, hauled across distances that required decades of organized effort, positioned with a precision that required generations of careful observation and aligned to the exact angle of sunlight on specific mornings of the year. Newgrange in Ireland was built around 5,000 years ago, before Stonehenge, before the Egyptian pyramids. It is a large mound of earth and stone, with a single narrow chamber inside, and a small opening above the entrance door. On the mornings around the winter solstice, for about 17 minutes, the rising sun shines directly through that opening and illuminates the chamber with light. The rest of the year, the chamber is dark. The people who built it did not have metal tools. They did not have writing. They did not have the wheel. And yet, they constructed a building that catches the sunrise of the shortest days with a precision that still works 5,000 years later. They knew exactly where the sun would be on that morning. They had been watching long enough to be certain. The sun was worth building for, worth organizing communities around, worth measuring with stone, worth passing down the knowledge of, through generations who had never learned to write anything else. We have not lost that reverence. We have only changed the instruments. The watching continues. The sun contains almost everything. More than 99% of all the mass in the solar system resides in the Sunday. Every planet, every moon, every asteroid and comet and dust grain, every ring and every captured rock in the Kuiper Belt and the Oort cloud, all of it together adds up to less than 1% of the mass of this system. Jupiter, the largest planet, the giant that contains more mass than all other planets combined, is still less than 0.1% of the Sun's mass. The Sun does not share the solar system. It is the solar system, in any meaningful gravitational sense. Everything else is a small remainder, a collection of leftovers from the Sun's formation, orbiting at various distances, held in various relationships with one another, but all of them ultimately orbiting the one thing that contains almost all of what was there to begin with. And yet the remainder is not nothing. The remainder is where everything interesting happened. Life, as far as we know, did not happen inside the Sunday. It happened in the leftovers. On a small, wet, tilted rock in the outer third of the habitable zone, in the remains of what the sun did not need. You are made of what the sun left behind. You exist in the space the sun did not consume, and from that small remainder, in those leftovers, something arose that could look back at the sun and wonder about it. The sun made almost everything, and what it did not make, it made possible. Even in deep winter, in the longest nights, something in you knows the sun is returning, not as a thought, as a feeling, as something older than thought, older than language, older than any story humans have told about the turning of the year. The body tracks the length of days. It measures the light. It registers, through mechanisms still being studied, the gradual shortening and then gradual lengthening of days, and responds with shifts in energy, mood, and metabolism that are not chosen but simply felt. The seasonal affective responses that many people experience in winter are not weaknesses. They are the body doing exactly what it evolved to do, conserving energy and withdrawing slightly during the dark months, preparing for the return of light the way animals prepare for the return of warmth. The body expects the sun to come back. It has always come back. The expectation is written into the biology as deeply as the sleep cycle, as deeply as the heartbeat. And the sun does come back, every year, without exception, for 4.5 billion years. The days begin to lengthen again after the solstice, by a minute here and a minute there. slowly accumulating light. The body notices before the mind does. Something lifts, subtly, before the calendar says it should. You have always known the light was returning, not because someone told you, because something in you, very old and very quiet, has been counting the days since before you were born. Darkness, it turns out, is not quite real, not total darkness, not anywhere in the observable universe, as best we can determine. Even the darkest patch of sky you have ever seen, the stretch of black between stars on a moonless night far from any city, is not truly empty of light. It is filled with the faint, cumulative glow of stars, too distant to resolve individually, of galaxies whose individual suns have blurred into a background warmth, of the cosmic microwave background radiation left over from the early universe, still arriving from every direction, still faintly present. True darkness, the complete absence of any photon, may not exist anywhere we could reach or measure. Light is simply too abundant, too persistent, too willing to travel for too long, in too many directions for darkness to ever be entirely complete. This does not make night any less restful. The darkness that lets you sleep is real enough for every purpose that matters. But underneath it, threading through it, arriving from distances that dwarf even the sun's reach, there is always light, ancient light. Light from sources that no longer exist in the form that made them, arriving now as the last whisper of something that burned out long before Earth was born. You rest tonight in darkness that is, at its finest resolution, not quite dark. You sleep inside a universe that has never fully switched its lights off. And the oldest of those lights, in a very real sense, has been traveling toward this moment since before the sun existed. Even in the deepest dark, you are held in light you cannot see. The mountains feel permanent. The sun finds them temporary. You have rested near mountains, perhaps, or seen them from a distance, the way they anchor a horizon, the way they seem to belong to a different category of time than everything around them. They are old in the way that makes human history seem recent. The Himalayas began rising 50 million years ago. The Appalachians, now rounded and gentle, were once as tall as the Alps, before hundreds of millions of years of wind and water reduced them to their current, quieter profile. And yet the sun has watched all of this. The Himalayas, from the sun's perspective, are a recent development, a slight rearrangement of the surface of a small planet, happening in what amounts to the final 10% of the sun's life so far. The ancient Appalachians, enormous and jagged when they formed, are a slightly older story, still well within the sun's memory, if the sun had memory. Every mountain range that has ever risen on Earth has risen and eroded within the sun's lifetime. The planet's surface has been completely rearranged multiple times, while the sun simply continued. There is something steadying in that, held the right way. The things that feel most permanent to us are brief by the measure of the thing that makes them visible, and the sun does not judge this. It simply illuminates what is there, for as long as it is there, and then illuminates whatever comes next. Light is not selective. It falls on what exists, without preference, without nostalgia. There are 8 billion people on this planet, and every single one of them shares your Sunday, not as a fact to rush past, as something to rest inside for a moment. 8 billion people, alive right now, on every continent, in every climate, speaking every language, living every kind of life that humans currently live. And every single one of them wakes up, if they wake up, into the same Sunday, the same fusion, the same ancient light, produced by the same star, arriving at a different face, a different window, a different morning. The sun does not know this. It does not distribute its warmth with any intention. It simply shines in every direction, and the spinning of the earth carries each face into the light in turn. But the effect is something that functions at a distance, like a kind of universal generosity. No one is excluded. No one receives a different Sunday. The light is the same light. You have something in common with every person alive right now, and with every person who has ever lived. Something so fundamental, it precedes language and culture and history. You all live under the same star. You have all felt its warmth on your face. You have all watched it set and trusted it to return. Whatever divides people, and many things do, the sun has never been one of them. It has always been shared, equally given, equally received by every open face that turns toward it. That is not nothing. On the scale of things that connect us, it is almost everything. The sun's light arrives with more than you can see. The visible spectrum, the range of wavelengths your eye is built to detect, is only a portion of what the sun sends. Below red is infrared, which you feel as heat rather than see as color. Above violet is ultraviolet, which you cannot see at all but which interacts powerfully with living tissue, producing vitamin D, causing sunburn, and driving the chemical processes that make certain flowers visible to bees in patterns invisible to human eyes. Beyond those are wavelengths further still, X-rays, radio waves. The sun emits across a broad electromagnetic spectrum, and what reaches the ground is already filtered by the atmosphere, which absorbs most of the harmful high-energy radiation before it arrives. The atmosphere is, among other things, a shield that selects which parts of the sun's output you receive. So the warmth you feel on your skin is the infrared portion. The light you see is the visible portion. The vitamin D your body is synthesizing is the ultraviolet portion. And all of these arrive simultaneously from the same source, doing different things to your body and the world around you at the same moment. You are bathed in more than light when you stand in the Sunday. You are bathed in a spectrum so wide that your senses only register a fraction of it. The sun is always giving more than can be received, more than can be used, more than can even be perceived. Abundance, for the sun, is simply the default. On Mercury, the sun would be terrifying, not in a dramatic sense, in a quiet, physical, unavoidable sense. Mercury has almost no atmosphere to soften or scatter the light. No blue sky, no haze, no diffusion of any kind. The sun hangs in a black sky, roughly 3 times larger than it appears from Earth, blazing with an intensity that would destroy unprotected eyes before they could register what they were seeing. The temperature on Mercury's surface facing the sun reaches over 400 degrees Celsius. The side facing away drops to -180. There is no in-between, no atmosphere to carry heat around the planet, to soften the transition from light to dark. Just the full, unmediated force of a star on one side, and the full cold of space on the other. What you experience as the sun, warm and familiar and safe, is already a translated version, softened by 93 million miles of distance, scattered and filtered and gentled by the atmosphere, arrived at a temperature your skin can enjoy, at an intensity your eyes can, with reasonable care, look near. The gentleness of sunlight, as you know it, is not the sun's own doing. It is the result of everything between you and the Sunday, the distance, the atmosphere, the particular arrangement of this planet that steps in front of the light and filters it for you before it arrives. You live inside a very precise act of protection, and the warmth you feel is warmth that has already been made safe for you by the particular mercy of distance. In 1919, starlight proved something extraordinary. During a total solar eclipse that year, the British astronomer Arthur Eddington led expeditions to 2 locations, one in West Africa and one in Brazil, to photograph the stars visible near the edge of the sun during totality. Stars that, under normal circumstances, would be invisible because the sun's light drowns them out. What Eddington found was that the stars near the sun's disk were not quite where they should have been. They were displaced slightly from their expected positions, bent inward toward the sun by a small but measurable angle. The sun's gravity was bending the path of their light as it passed close by. This was the prediction Einstein had made with his general theory of relativity, published 4 years earlier. Gravity, he had proposed, was not a force between masses, but a curvature of space-time caused by mass. Light, traveling through curved space-time, would follow that curvature and appear to bend. The sun confirmed this. Its gravity was measurable not through any object it pulled toward itself, but through the way it bent the light of distant stars around its edge. The universe was geometrically shaped by mass, and the proof arrived on photographic plates during 2 minutes of totality. From the star we have always known best, the sun did not just warm the earth that day. It demonstrated, to the satisfaction of the watching world, the deep structure of reality. Even as you rest right now, the sun is listening to itself, not with any intention, not with any awareness, but through the physics of its own convection. The sun produces pressure waves that travel through its interior and across its surface, causing it to oscillate in patterns that carry information about its internal structure. These oscillations are the acoustic vibrations we call helioseismology. They are the sun's own voice, reflected back through itself. Scientists study these oscillations the way geologists study earthquakes. By measuring how the waves travel and how long they take, and how they are deflected, they can infer what the interior must look like, the density of different layers, the rotation rate at different depths, the presence of the tachocline, that hidden boundary layer where the magnetic field is thought to originate. The sun cannot be opened. It cannot be drilled or sampled or visited. Its interior is sealed behind a surface temperature of 5,000 degrees and the simple physical impossibility of surviving anywhere near it. And yet, through its own sound, it tells us what it contains. There is something quietly remarkable about that. The sun communicates its interior through vibration, through the oscillations of its own body, and we have learned to read that communication. We have built instruments sensitive enough to hear a star singing to itself, and careful enough to decode what the song means. You are resting near a planet that has learned to listen to a star, and the star, without knowing, has been answering. Light is already gentle by the time it finds you. It left the sun without any particular softness. At the surface, a photon carries more energy than your skin could comfortably receive directly. The raw output of the sun, unfiltered, is not gentle. It is intense in the way that only a star can be intense, in the way that only fusion can be intense, in the way that only something doing what the sun does for billions of years could sustain. But between the sun and you, many things intervene. Distance reduces intensity, according to a precise mathematical law. Double the distance, reduce the intensity to a quarter. By the time sunlight has crossed 150 million kilometers, it has already been softened enormously just by the journey. Then the atmosphere does its work. Ozone absorbs the most harmful ultraviolet. Oxygen and nitrogen scatter the shorter wavelengths. Cloud, when it is present, diffuses everything further, spreading the light in every direction, turning a single directional source into a general, enveloping glow. What lands on your skin is the result of all of that. of distance and scattering and filtering and diffusion, of 100 different processes, each one reducing and redirecting and transforming the light until what arrives is something your body can receive without harm and with something close to pleasure. The sun sends more than you can use. Everything between you and the sun works to bring it down to something you can bear. And what arrives, finally, is warmth. Just warmth. Enough. Exactly enough. The sun writes its name in every beam of light it sends. Not visibly, not in any language you could read with your eye, but embedded within sunlight. If you pass it through a prism and look carefully at the spectrum of colors that emerges, there are dark lines, hundreds of them, precise and repeating and permanently present. Each one is the signature of a specific element in the sun's atmosphere, a place where that element has absorbed a particular wavelength of light before the beam could escape. Hydrogen leaves its mark. Sodium leaves its mark. Iron, calcium, magnesium, helium. Each one takes something specific from the light as it passes through, and the taking leaves a gap, a dark line, a record of what was there. The spectrum of sunlight is not a smooth rainbow. It is a rainbow with a message written in it. This is how we know the sun's composition without ever touching it. We read the message it writes in its own light, and the message is consistent. Every beam of sunlight carries the same fingerprint. Every photon that reaches your window this morning arrived with the same dark lines embedded in it, the same record of the elements it passed through on its way to you. The sun has been sending this message for 4.5 billion years, to every surface that could receive it, to the ocean, to the rock, to the earliest photosynthetic bacteria, to the dinosaurs, to every human who has ever held a prism up to a window. It has always been telling us what it was made of. We simply needed to learn to read the light. Even after the sun sets, the sky holds its warmth a little longer. Not the warmth exactly, the light, the color, the particular quality of illumination that happens in the minutes after the sun has moved below the horizon, when the sky itself is still lit from beneath and the world below has already darkened, and there is a brief window when everything is visible, but nothing casts a shadow. This period is called civil twilight. It lasts until the sun is 6 degrees below the horizon, and during it the sky holds a color that has no precise name in most languages, a deep blue that is not yet night, a softness at the edges of things, a quality of light that painters have always chased and never quite reproduced, because it changes every second and is gone before you can hold it. After civil twilight comes nautical twilight, then astronomical twilight, then true night. Each stage is a further degree of the sun's departure, the sky responding to the geometry of the Earth's shadow, the atmosphere still catching and scattering light from a sun that is already, technically, gone. The sky is reluctant to lose the light, or so it seems, watching it, as if the air itself knows something worth keeping, and holds it a little longer than it has to. You have watched this, perhaps without the name for it, perhaps just as a feeling that the evening was taking its time, that the day was leaving slowly, gently, with no particular urgency to be done. The light agrees with you. It always leaves slowly. It has never been in a hurry to go. The sun has risen every day for 4.5 billion years. Not almost every day, not most days, every single day, without exception, without pause, without any mechanism that could cause it to fail at this particular task. The Earth has rotated. The sun has been there. The light has arrived. This has happened approximately 1.6 trillion times since the sun and Earth formed together from the same collapsing cloud of gas and dust. 1.6 trillion sunrises, before any eye existed to see them. before any atmosphere existed to color them, before oceans, before continents, before single-celled life, before complex life, before anything we would recognize as living, the sun rose, the planet turned, the light arrived. And tomorrow it will happen again, not because anything is maintaining it, not because anyone is watching to make sure, because the physics that governs the rotation of planets and the output of stars is so stable, so consistent, so deeply written into the structure of the universe, that a sunrise tomorrow morning is as close to a certainty as anything in the physical world can be. You can rest tonight with this, with the knowledge that the morning is not in question, that the light is not something you need to worry about, that while you sleep, the planet is carrying you toward the sun, and the sun is waiting there, as it always has been, as it always will be for longer than you need to think about tonight. The sunrise is not a gift you have to earn. It simply comes. It has always simply come. Falling asleep as the sun sets is one of the oldest things a human body can do. Older than agriculture, older than fire, in its controlled and deliberate form, older than language, older than any tool more complex than a held stone. The body responding to the fading of light by growing heavy and slow and ready for rest is a behavior so ancient that it predates the genus Homo. It predates primates entirely. The circadian response to darkness is shared by creatures that diverged from our lineage hundreds of millions of years ago. When you feel sleepy at the end of a day, when the light dims and your eyelids grow heavy and the thoughts begin to lose their edges, you are doing something your ancestors did, and their ancestors, and the ancestors before them, all the way back through the long, unbroken chain of lives to something small and early and close to the ground that felt the dark arrive and knew to be still. The sun shaped that response. Millions of years of light and dark, predictably alternating, selecting for creatures that used the dark to rest and the light to move. Your sleepiness tonight is the sun's design, written into your body by a process so old it has no beginning you could point to. You are not fighting sleep. You are obeying something ancient and generous, something that has kept living things safe and restored for longer than the concept of safety existed. Let your body do what it has always known to do. The sun has already set. The dark is already here. Everything is proceeding exactly as it should. The sun travels with companions, not in the way we imagine stellar companionship. It has no binary partner, no nearby star orbiting in a shared dance. It moves through the galaxy largely alone, in the orbital sense, but it moves through a neighborhood, through a region of the Milky Way that contains thousands of other stars, each one on its own long, slow path around the galactic center, each one near enough to the sun, in galactic terms, to be considered a local resident. The nearest of these neighbors is Proxima Centauri, a small red dwarf star approximately 4 light-years away. In the vast scales of the galaxy, this is quite close. In any human scale, 4 light-years is a distance that would take our fastest spacecraft tens of thousands of years to cross. And yet the sun is not alone. Over the billions of years of its orbit around the Milky Way, it has passed through different stellar neighborhoods, come near different stars, moved through regions of the galaxy with different densities of dust and gas. The sun's journey is not through empty space. It is through a slowly changing community of stars, each one on its own ancient path, occasionally near enough to matter gravitationally, always part of the same vast turning system. Tonight, as you rest, the sun is moving, not toward anything in particular, not away from anything it has left, simply continuing its long, unhurried path around a galaxy that will still be turning long after the sun itself has cooled. It is, in its own way, just passing through, as everything is, eventually, just passing through. When you sleep, the sun is rising for someone else, not as a poetic thought, as a fact of geometry, playing out right now on the surface of a spinning planet. As you move towards sleep, or rest in the early part of the night, somewhere on the other side of the world, in a city or a village or a stretch of coast you will never visit, the sky is turning from black to the particular dark blue that comes just before dawn. Someone is awake in it, or waking into it, feeling the air begin to change the way air changes in the last hour before sunrise. The sun rises for them as genuinely as it has ever risen for you, with the same quality of light, with the same long shadows of early morning, with the same birds, or different birds, beginning, with the same ancient response in a body that recognizes the return of light even before full waking. You are sharing this moment with them, in a way that requires no communication and no awareness on either side. They do not know you are resting as they wake. You do not know their name, or their window, or the particular color their sky turns just before dawn. And yet you are connected by the same sun, doing the same thing it does, turning with the planet, giving each face its morning in turn. There is something restful in that. You do not need to be awake for the sunrise to happen. You do not need to witness it to receive its warmth tomorrow. The sun does not require your attention to do its work. It rises whether you watch or not, and it will be there when you open your eyes. Melatonin is a small molecule with a long memory. It is produced by the pineal gland, a tiny structure deep in the brain, in response to darkness. As light fades, the suppression of melatonin production is lifted, and the molecule begins to accumulate in the bloodstream, signaling to every cell in the body that night has come and the long process of rest and repair can begin. The pineal gland has been producing melatonin in the brains of vertebrates for hundreds of millions of years. In some reptiles and amphibians, it sits close enough to the surface of the skull to detect light directly through the skin, a third eye of sorts, reading the brightness of the world without requiring the visual system at all. In mammals, it relies on signals from the eyes, but the fundamental mechanism is the same. Darkness means melatonin. Melatonin means rest. You share this with fish, with frogs, with the ancestors of birds, with every creature that has ever lived on this rotating planet and needed to know when to be still. The molecule moving through your bloodstream right now, gently slowing things down, gently preparing you for sleep, is one of the oldest biological responses to the sun that exists in complex life. It evolved in the presence of this star. It was shaped by this star's rhythm. It carries, in its chemistry, the memory of billions of nights exactly like this one. Your body knows how to do this. It has always known. The sun taught it, long before you were born. A sunbeam crossing a dim room is 150 million kilometers made visible. Not the whole journey, just the last few meters of it. The part where the light, which has been traveling freely through the vacuum of space for 8 minutes and 20 seconds, enters an atmosphere, enters a building, enters a room, and finally encounters enough dust in the air to make itself visible as a beam. The dust is essential. In perfectly clean air, a beam of light is invisible from the side. Light does not glow as it travels. It only reveals itself when it strikes something. The particles of dust floating in the shaft of a sunbeam are not interrupting the light. They are making it visible. They are the screen on which the journey announces itself. Each of those dust particles is tiny beyond easy imagining, and yet together, they are enough to catch the light and scatter it sideways into your eyes so that you can see the beam itself. not just its destination, so that you can see the light in the act of traveling. A sunbeam in a quiet room is one of the most common sights in the world, and one of the most overlooked. It is also, if you let yourself see it fully, a piece of a star arriving in your living room, the same light that will warm the grass outside, the same light that travels across interplanetary space, slowed and scattered by a few specks of dust, into something you can stand in the middle of and feel on your skin and watch moving across the floor as the earth turns. The ordinary is often the extraordinary, resting quietly in a familiar shape, waiting to be recognized. Somewhere in the Milky Way, the sun has neighbors it has never met. Not in the human sense of meeting, but in the sense that other stars exist within the sun's general region of the galaxy, moving on paths that have brought them near and will bring others near in the future, close enough in galactic terms to have been, at various points in the sun's long orbit, something like local company. Stars drift. Over millions of years, the slow gravitational choreography of the galaxy shifts which stars are near which others. The sun's current neighbors are not the same stars that were nearby when Earth was young, and the stars that will be nearest to the sun in 1 billion years have not yet arrived in its neighborhood. The galaxy is always slowly rearranging itself, like a very large and very patient crowd in which everyone is moving but no one is in a hurry. What this means is that the sun's context changes. The interstellar medium it passes through changes. The density of nearby stars changes. The sun is not fixed in a permanent position within the galaxy. It is a traveler on a very long path, and the view from that path is always, on the scale of geological time, slowly different. You live on a planet orbiting a star that is itself on a journey. The solar system is not a destination. It is a vehicle, moving through the galaxy at roughly 220 kilometers per second, in a long, slow arc around the galactic center that takes 230 million years to complete. You are, even now, going somewhere. The destination is simply too far ahead to see. Even your sleep is solar. We have touched this before, but only at the surface. The connection runs deeper than melatonin, deeper than the circadian rhythm, deeper than the simple on-off of the sleep signal. The quality of sleep, not just its timing, is shaped by light, by how much light you received during the day, by what wavelengths reached your eyes, by the particular arc of brightness and dimming that the sun traces from dawn to dusk. Sleep researchers have found that people who receive more natural light during the day, especially in the morning hours, when the sun is lower and its light is angled and rich in the wavelengths that reset the circadian clock, sleep better at night. They fall asleep more easily. They spend more time in deep, restorative sleep. They wake more naturally, with less resistance. The sun is not just telling your body when to sleep. It is telling your body how to sleep. It is calibrating the depth and quality of the rest you will receive, hours before the rest begins, through the simple act of being present in the sky and offering its light to whatever face is turned toward it. Your sleep tonight, the quality of it, the depth of it, the ease of it, was partly shaped by the sunlight you received or did not receive today. The sun has been preparing you for this moment since morning. Rest, then, in that preparation. The work has already been done. The sun has already done its part. A photon that has waited 100,000 years deserves a soft landing. It was born in the core, in the crush and heat of fusion, and it spent longer than human civilization has existed, simply trying to escape the interior of the star. Random walking through plasma so dense that every direction was a wall, being absorbed and re-emitted, making no meaningful progress for spans of time that dwarf all of recorded history. And then it reached the surface, and the surface released it, and it crossed 150 million kilometers in 8 minutes and 20 seconds. And then it arrived here, on this planet, and it struck something. Maybe it struck a leaf, and its energy was captured by a chlorophyll molecule and converted into sugar. Maybe it struck a solar panel and became electricity. Maybe it struck the surface of the ocean and became heat, warming the water slightly, contributing fractionally to a current that will travel the world over centuries. Maybe it came through a window. Maybe it fell on a face. Maybe it landed on closed eyelids and was felt as warmth in the last minutes of an afternoon before someone went inside. Every photon that reaches Earth has made that journey. The ancient interior struggle, the swift crossing of space, the arrival. All of them deserve, in some small poetic sense, to land on something that can receive them. Something warm and present and alive. You have been receiving them all your life. And tonight, even as you rest, the ones that landed today are still doing their quiet work inside you. The sun holds you in your orbit and asks for nothing. Gravity is not a transaction. The sun does not require anything of Earth in return for the gravitational relationship that keeps this planet in its loop. It does not need Earth's presence. It would continue, largely unchanged, if Earth were not here. The pull is not intentional. It is simply the consequence of mass existing in space and curving the space-time around it. And yet the result, from Earth's perspective, is something that functions like perfect reliability. The sun has maintained this relationship for 4.5 billion years without interruption, without varying the terms, without any change that would threaten the orbit in any meaningful way. Earth has gone around, and the sun has held it, and this has continued for a span of time so long that every other thing you can name has changed many times over within it. Continents have moved, oceans have opened and closed, species have come and gone in their millions, climates have shifted from ice to warmth and back again. The sun has continued, the orbit has continued. The relationship between this planet and this star has been one of the most stable things in the history of the solar system. You are held tonight by something that has never let go, not because it chose not to, not because it remembered to, simply because letting go is not in the nature of what gravity is. Some of the most reliable things in your life have no mechanism for forgetting you. They simply continue, as the sun continues, as the orbit continues, as the light continues, arriving each morning as it has always arrived, holding as it has always held. Right now, on the far side of the sun, something is happening that you will never see. The sun rotates, as we have noted, in that slow differential turn, equator faster than poles. And the hemisphere currently facing away from Earth is doing everything the hemisphere facing us is doing. Granules rising and falling, sunspots moving with the rotation, plasma convecting in slow, enormous columns. The same processes, the same dynamics, the same ancient steady fusion in the core, pouring energy outward in all directions equally. Space observatories, including the stereo missions launched in 2006, have allowed scientists to observe portions of the sun's far side for the first time, using pairs of spacecraft positioned at different points in their own orbits to triangulate the sun's full surface. The data revealed that the far side behaves as expected, the same, largely, as the side we see. The universe continues to do its work whether or not we are watching. The sun does not perform only when observed. It does not save its activity for the hemisphere facing Earth. It simply does what it does, in every direction, at all times, without any relationship to whether a small planet with eyes happens to be facing it. Most of what happens in the universe happens unobserved. Most of what the sun does is seen by no one, and it continues anyway, reliably, completely, with the same energy and the same fusion and the same warmth in every direction. The sun does not need to be watched to shine. It simply shines. The sun will not end. It will transform. There is an important distinction there, held gently. When the sun eventually exhausts the hydrogen in its core, in roughly 5 billion years, it will not stop. It will change. The core will contract and heat further, and the outer layers will expand, and the sun will become a red giant, and eventually the outer layers will drift away as a planetary nebula, a shell of gas expanding slowly into space, and the core will remain as a white dwarf. But the white dwarf will not be nothing. It will be a dense, hot object, roughly the size of Earth, slowly radiating the heat of its formation into the universe, cooling over trillions of years, from white to yellow to orange to red to something dark and cold for which we have no name yet, because no white dwarf has had the time to reach it. The universe is not yet old enough, and even that cooling object will still be there, still made of the same carbon and oxygen that the sun's fusion produced, still occupying the same region of space. Still, in some sense, the sun just changed, just quieter, just further along, a process that has no final ending point we can identify, only a gradual dimming that continues for longer than the current age of the universe. Nothing is lost. Things change form. Things change scale. Things grow quieter over spans of time that make our own spans of time feel like the briefest flicker of a candle in a very large, very patient room. The sun is not going anywhere. It is only, slowly, becoming something else. Somewhere above you, the Parker Solar Probe is still flying. Right now, as you rest, a small machine the size of a car is making its way around the sun on an elliptical orbit that brings it closer to the star than any human-made object has ever been. It has already entered the corona. It has already touched the outer atmosphere of the sun, flying through the region of mysteriously extreme temperatures that scientists are still working to understand. It carries instruments built to measure the solar wind, the magnetic field, the plasma waves in the corona, the dust near the sunday. It carries a memory card with the names of over 1 million people who submitted them to travel with the probe. It carries, in its small and purposeful way, a piece of human curiosity toward the thing that has always been there, always overhead, always fundamental, and never quite fully known. The heat shield protecting it is made of carbon composite, painted white on the sun-facing side, to reflect as much energy as possible. Behind that shield, in a cone of shadow that the probe maintains by always keeping the shield between itself and the sun, the instruments operate at room temperature, a careful, engineered darkness, maintained in one of the brightest places in the solar system. We sent something to meet the Sunday. We built it carefully, and aimed it well, and let it go. And it is still going, still gathering, still sending data back across 150 million kilometers to people sitting at screens on a small planet, reading what the sun is doing up close. We are curious creatures. And the thing we are most curious about, the thing closest to us, the thing most responsible for our existence, is still, after all this time, surprising us. Every morning of your life, the sun has been there, not waiting, not watching, not in any sense that implies intention or awareness, but present, consistently, reliably, without a single exception across every morning you have ever lived. The light has returned, the warmth has arrived, the day has come, and you have been here in it, sometimes noticing and sometimes not, sometimes grateful and sometimes simply going about the business of being alive in the light of a star. There have been mornings you were too busy to notice the quality of the light. Mornings you woke before dawn and watched the sky change and felt something you could not name. Mornings you slept through entirely and woke to a day already well underway. Mornings after difficult nights, when the return of light was something close to relief. Mornings so ordinary they left no memory. The sun was there for all of them, consistently, without variation in its commitment to the task. If commitment is even a word that applies to physics, it simply did what it does. It appeared, it warmed, it set. It waited in its absence for the rotation to bring you back around. You have lived your entire life inside a relationship with a star, whether or not you have ever thought of it that way. Every day of your existence has been a day lit by the same source. Every morning has been a return to the same warmth. That is not ordinary, exactly. It only feels ordinary because it has always been there. But always having been there is not the same as ordinary. It is something closer to devotion. And tonight, resting in the quiet after another one of those days, it is worth feeling, just briefly, how much has been given without being asked for. Your body is still holding today's light, not as memory, not as warmth you can still feel on your skin, but as chemistry, as process. The ultraviolet light that reached you today, even through cloud, even filtered by glass, set off a chain of reactions in your skin that is still running as you lie still. Vitamin D precursors are being converted. Signals sent earlier in the day are still traveling through systems that work on their own quiet schedule, independent of your awareness, independent of whether the sun is still above the horizon. The body does not experience the sun only in the moment of exposure. It carries the conversation forward, into the evening, into the night. The light you received this morning is part of what is happening in your body right now, as you rest, as your breathing slows, as the long process of repair and restoration that happens only in sleep begins its careful work. You went inside hours ago. The sun set, and still it is present in you, in the most literal biological sense, doing what it set in motion during the day. The conversation between your body and the star is not interrupted by darkness. It simply continues in a different register. Less receiving, more processing, more using what was given. Tonight, your body is the sun's quiet workshop. Everything received today is being sorted and used and stored. And tomorrow you will step back into the light, and the conversation will resume, and the body will receive again what it has always received, from the same ancient and generous source. The sun does not leave when it sets. It simply changes the form of its presence. 8 minutes ago, the sun was still shining. Not 8 minutes ago in any sense that matters to the night you are resting in, but physically, precisely. The light arriving anywhere on Earth right now left the sun 8 minutes and 20 seconds before it arrived. Every photon that touches the planet does so with a slight delay, carrying a message that is always, by the time it lands, fractionally old. This means that if the sun were somehow to stop, you would not know for 8 minutes and 20 seconds. The light would continue to arrive. The warmth would continue. The sky would remain blue. And then, at the moment the last photon sent before the stopping reached the ground, everything would change. But the sun has not stopped. There is no mechanism by which it could stop on the timescale of anything that matters to a human life. The fusion continues. The light continues. The message is always the same, and it always arrives with the same small delay, the same 8-minute gap between the sending and the receiving. What this means, gently, is that you are never quite in the present with the Sunday. You are always receiving its past. The warmth on your face is always slightly historical. The light in your eyes is always a brief memory of a star. And that star, in the time between the sending and the receiving, has continued, has burned a little more, has sent more light, has always, by the time anything reaches you, already moved on. The sun is always slightly ahead of what you can receive of it, and still it is more than enough. The light arriving on Earth right now left the sun before you woke this morning, and the light that will greet you tomorrow morning left the sun before you fell asleep tonight. It is already on its way, already crossing the 150 million kilometers of space between the star and your window, already committed to its arrival, already traveling at the speed that nothing in the universe exceeds, already aimed, by the geometry of the solar system, at the particular patch of sky that will be your morning. You do not need to do anything to receive it. You do not need to be awake for it to leave the Sunday. It departed before you made any decisions about tomorrow, before you knew whether tomorrow would be easy or difficult or somewhere in the quiet middle where most days live. The morning light is already in transit, already yours, in a sense, already on its way to the window you will open, or the door you will step through, or the sky you will look up at. It was sent before you asked for it, and will arrive whether or not you are watching for it. There is something deeply settling in that. The light does not wait for your readiness. It simply comes. It has always simply come. And while you sleep, it is already on its way to you, crossing the dark between stars, covering the distance at the only speed it knows, faithful and unhurried, and already almost here. You are a child of a star, not in the way a metaphor works, arriving to make something feel larger than it is, in the way that chemistry works, traceably, verifiably, from the first principles of nuclear physics to the specific composition of your blood and your bones, and the carbon rings that form the molecules of every living thing you have ever been or touched. The calcium in your teeth was forged inside a star that died before the sun was born. The iron carrying oxygen through your blood right now was produced in the core of a massive star and scattered into space when that star ended its life in a supernova. The carbon threading through every cell of your body, the backbone of every organic molecule, was built from helium in stellar interiors across billions of years of stellar evolution before this solar system existed. You are not made of star stuff in the poetic sense. You are made of star stuff in the only sense that matters, the literal, physical, elemental sense. Every atom in your body has a history that begins inside a star. Every element heavier than hydrogen and helium was forged in stellar fusion or in the violence of stellar death and scattered into the clouds that became new stars and new solar systems and, eventually, you. The sun did not make you directly, but the process that makes the sun, the process of stellar evolution and death and the scattering of elements into space, is what made the raw materials of every living thing. You are the universe's way of taking old starlight and giving it a body and a heartbeat and a quiet night to rest in, at the end of a day lit by a star. The facts are done now. There are no more to offer. Only this, the quiet that was always underneath them, the stillness that the information was pointing toward all along. You have been traveling tonight, from the familiar to the vast, to the intimate, to the open. And now the traveling is done, and what remains is simply this moment, and your body in it, and the dark around you, and the star that is, right now, on the other side of the world. Feel the weight of where you are, the particular pressure of whatever surface is beneath you, the temperature of the air near your face, the rhythm of your own breathing, which has been happening without your attention all evening, steady and sufficient, as the sun is steady and sufficient, doing its work without requiring your awareness of it. Your body is cooling slightly, as bodies do in the hours of the night. Your heart rate has slowed. The signals moving through your nervous system are growing quieter, less urgent, more content with simply maintaining what needs to be maintained. You are, in the language of biology, entering rest. In the language of tonight, you are becoming still. The sun is somewhere below the horizon right now. Not gone, never gone, simply on the other side of the curve of the earth, shining on other faces, warming other mornings, sending its light in every direction as it always does, including toward the planet you are resting on, held in its orbit as you have always been held. Even now, the solar wind is moving past this planet. The neutrinos are passing through you, fresh from the sun's core, carrying news of fusion happening at this exact second, passing through the ground beneath you, through the building around you, through the quiet body that is you, and continuing outward into space beyond. Even now, somewhere above the atmosphere, the corona is burning at its mysterious millions of degrees, and scientists somewhere are looking at data from instruments trained on the sun, reading the oscillations, the magnetic field, the plasma waves, trying to understand a little more of what the closest star is doing and why. And even now, in a field somewhere, sunflowers are facing east in the dark, waiting for the morning they have already oriented themselves toward, already aimed at what is coming, already ready. You have been breathing the sun's work all evening. Every breath of oxygen in this room passed through a plant. Every plant that made it did so in sunlight. The air you are breathing right now is 4 billion years of photosynthesis, accumulated slowly, patiently, by organisms that asked nothing of you and gave you everything you need to keep going through the night. Let that breath be slow. Let it be easy. There is more than enough air. There has always been more than enough. The sun has been making it through every living thing it has ever touched, for longer than anything alive today can remember. Your chest rises. Your chest falls. The exchange happens without effort, without decision, without any action on your part, beyond the simple willingness to let the body do what it has always known how to do. The sun made the air. The air is keeping you, and you are resting in the middle of all of it, held by gravity, held by orbit, held by the particular arrangement of this planet and this star that has been stable for 4.5 billion years and will remain stable for longer than you need to think about tonight. The morning light has already left the Sunday. It is on its way. Right now, crossing the dark between the star and the planet, covering the distance at the speed that nothing exceeds, aimed at the particular morning that is waiting for you on the other side of this night. It does not know your name. It does not know your window. But it is coming as it always comes, faithful to the physics that sends it and the geometry that aims it and the rotation that will carry your face back into it when the time arrives. You do not need to stay awake for it. It does not require your attention to make the crossing. Sleep, and the light will come anyway. Rest, and the morning will arrive as it has always arrived, unannounced and sufficient and warm in the particular way that only sunlight through a morning window can be warm. Let the body grow heavy. Let the thoughts grow loose and slow and less attached to their own endings. Let the dark be what it is, the space the sun leaves when it moves on, the generous absence that allows rest, the other half of a rhythm so old that your body has been keeping it since before you were born. Somewhere, right now, the aurora is moving. In the high latitudes of both hemispheres, where the sun's breath and the earth's shield meet and glow, curtains of light are shifting in the dark sky, green and violet and sometimes red, folding slowly, following the invisible lines of the magnetic field. lighting the faces of the few who are awake and standing in the cold to watch them. They do not know you are resting. You do not know they are watching, and yet you share the same sun, the same solar wind that makes those lights, the same planet whose magnetic field guides the particles into color. You are connected to every person standing under auroras tonight by the same source, the same breath of the same star doing its quiet, ancient work. The world is lit tonight in its various ways, here by darkness and rest, there by auroras, somewhere else by the first pale blue of a dawn that has not yet arrived, but is already close, somewhere else by the full white light of noon, all of it the sun, distributed across a rotating planet, offering each face what the geometry of the moment allows. Let yourself be the resting part of that, the quiet part, the part that has received enough for one day and is now simply being still inside all that has been given. Your bones are older than the sea. We began there, tonight, with the calcium in your bones, forged in a star that died before Earth had oceans. And now we have come all the way around, through the humming of the sun and the patience of photons and the silence of neutrinos and the ancient calibration of your circadian rhythm, back to this, your body, resting, made of things older than the world you rest on. You are ancient matter, briefly arranged into something that breathes and feels and wonders. The star stuff that makes you has been through many forms before this one. It has been part of clouds and rocks and seas and living things that have no names because no one was there to name them. And after you, it will be part of other things, other arrangements, other brief and wandering forms that the universe has not yet assembled. But right now, in this arrangement, in this body, on this night, you are here, resting, breathing the sun's work, held in the sun's orbit, warmed by a star whose light left before you woke this morning, and will arrive again before you have decided anything about tomorrow. You are here. You are held. The universe has been at this for a very long time, and it has not let you go yet. Let the night be quiet now. Let the facts rest where they landed. Let the images settle, the way light settles on a surface and simply stays there, warm and still, doing nothing more than being present. The sun is below the horizon. The planet is turning. Your body knows what to do with the dark. It has always known. It was taught by a rhythm older than memory, calibrated by a star that has been rising and setting for 4.5 billion years without a single missed morning. You are in good hands, not metaphorically, gravitationally, held in an orbit so stable it has not varied enough to matter in all the time life has existed on this planet. Held by the same force that holds the comets, the same force that holds the Voyagers, the same quiet and immense and completely reliable pull of a middle-aged star going about its ordinary, extraordinary work. The breathing can slow now. The thoughts can soften. The long, patient dark can do what it came to do. Outside, the world continues its quiet business. Somewhere a sunflower faces east. Somewhere the aurora folds and shifts. Somewhere a photon born in the sun's core 100,000 years ago is landing, finally, on something warm. And here, in this room, in this body, in this particular moment of a universe that has been building toward moments like this one for longer than the sun itself has existed, there is simply rest, simply stillness, simply the soft and ancient dark, and the star behind it, and you. I hope you sleep well, and dream softly. Good night.